So quick refresher on circle. Talked about how using the distance formula. And then we talked about how this would be the standard equation of a circle, x minus h squared plus y minus k squared equals the radius squared, where h and k are your center and r is the radius. And then we talked about how to graph the circle, the radius, and the center, and count up, down, right, left, whatever. So let's say that my center was, instead of 0, 6, let's say it was -1, 5, and the radius was 7. How could you find the equation of that circle? So given the center is -1, 5, and the radius is 7. Keep going, x plus 1 squared.
Plus y minus 5.
Good. Which would be? 49. Good. All right, and then the other question would be, if you had the equation, could you take out the center and the radius, and could you graph it? Okay, that's basically where we were at yesterday. And then we said if we this, and we got to here, right? Yep. So we found the equation if we were given a point. So let me go back. If you weren't given the center and the radius, but you were given something like this, the center and a point that contains the circle, which would be...
Pardon the interruption. Jenna Vaughn, please report to student services. Jenna Vaughn, please report to student services. Thank you.
So a circle, something like that, okay, where the center's at -3, 5, so that's still my HK, I already have that part. And then it contains the point 9, 10. So what did we say was missing in a problem like this? The radius. And how did we say you could find the radius? Good. Distance from the center to that point, 9, 10. So remember the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So you're going to use the center and the point, and it doesn't matter which ones you make the 1s or which ones you make the 2s, as long as within the parentheses they're the same. Ian?
I have 2 questions.
Mm-hmm.
The first one is, if you see the center and the point, you're finding the radius?
Correct.
Okay. And then...
Let's say, a variation on this could be, what if they gave you the endpoints of a diameter? You'd have to use the midpoint formula to find the center, and then, which goes back to what we did in that first section, and then you'd have to find the radius, and then you could use those two. But typically they're going to give you like this, like the center and either the radius or the center and a point on the circle, and you have to find the radius.
And when it's containing the point, it means that it's on the circle?
It means that point is on the circle, correct. Yeah. So I could say that this -3, 5, which is my center, is my x1, y1. And I could say 9, 10 is my x2, y2, and plug it in. So the square root of 9 minus a -3 becomes +3. Squared plus 10 minus 5. I get the square root of 12 squared plus 5 squared. The square root of 144 plus 25. Square root of 169, which is 13. So this represents the segment that would connect the center to a point on the circle, which is your radius. But we don't even need to go to this next step unless it asks explicitly for the radius, because when we put it back in the equation, we're squaring it. So then I would get x minus the h, so x minus a -3 becomes x plus 3 squared, plus y minus 5 squared equals the radius squared, which is 169. So just be careful on problems like these. Make sure that you're when you plug back in, that you're using the point that's indicated as the center and not the one that's on the circle. Okay, that's how a mistake could be easily made with this one. Like 9, 10 is not the point that goes in as a center. It's obviously the one that's -3, 5. The distance one or the standard? That's the one on the bottom. This is the standard. So this is that x minus h plus y minus k equals the radius squared. So that's the standard equation of the circle. So once you have the center and the radius, we had to use distance to get the radius, but then once we have the center and the radius, you just plug it back into that standard equation. Because it's x minus h, and h is a -3. So x minus a -3. Remember when you look at the point versus the equation, the signs will always be opposite. So if the point's negative in the equation, it's gonna be positive and vice versa. If it's positive in the equation, when you pull it out, it becomes negative. Because your original equation is a minus. Questions overall on any of it? Okay, so instead